This is VB, one input signal connected to the one op amp. This is VA, which is connected to the another input of the op amp. Okay. So now, as I said in the previous video, so VB can be measured using a voltage divider circuit here. So VB is nothing but RB into VDC divided by RB plus RC. If I arrange this equation properly or in the circuit, we can get that expression. Similarly, for VA also, here RA is connected to ground, means we are going to measure VA at the resistance RA, it is connected to ground. Okay. So now RT is directly connected to the VDC, so which is connected to the ground. So this is another voltage divider circuit. So from this we can say that VA is nothing but VA equals to, so VDC into RA divided by RA plus RT. So like this, two input voltages can be obtained using this bridge circuit. Okay. Now VA is applied to the non-inverting terminal of this op amp, and VB is applied for this non-inverting terminal of another op amp, whereas inverting terminal is directly connected to the output side as a feedback here. Okay. So that we can control the gain. Okay. So now at this term or at this input of the third op amp, here I will get it as VA and here I will get it as VB. So from this I can say that here we can write this is VA here and this is VB here. Okay. So here now this op amp acts as a differential amplifier, where the complete input for this we can call it as VAB. So now I can say that here from this we can write here VAB is nothing but, we can say that VB minus VA. So this is the total input which is at the op amp 3. Okay, at the third op amp we can get, this is the input. Now we have to find out what will be the VAB using this bridge and these two op amps outputs. Okay, so now, so we'll focus on this when I comes to explain that. Here first thing, we know that VB equals to VA because when the bridge is said to be balanced. So when VB equals to VA, so we can say that the value of VB is nothing but, according to voltage division rule, RB into VDC divided by RB plus RC, which is I explained earlier, where VA is nothing but RA into VDC divided by RA plus RT. So RT can be changed as RT plus or minus change in R, depends on the user. So here bridge is said to be balanced, then RC by RB equals to RT by RA. Okay. Similarly like VB equals to VA. Now these are the signals and the equations now. So now, so if I substitute them here, where VA, once the physical quantity of this bridge is changed, nothing but if I change the physical quantity here, here the bridge can be balanced or unbalanced based on the selection of this resistor now. So now what I can write here, so using this expression here, so we can write VA equals to RA into VDC divided by RA plus RT plus change in R. So this change in R is added here just because we are going to change that physical quantity. Okay. Whereas VB is constant because RB, RC and RA are fixed. So therefore VB remains same here. Okay. Now we know that the voltage VAB across the output terminal of the bridge is VAB equals to VA minus VB, or you can say that VB minus VA. So based on the selection of op amps here. So now, so from this we can say that here we will get the VAB value, which is can be written as VA minus VB or VB minus VA. This will be decided based on the selection of the output. So here we have taken it as VAB equals to VA minus VB here. Okay. So here we got it as VAB equals to VA minus VB. So now substitute the value of VA and VB here, we will get VAB. Then assuming that RA equals to RB equals to RC equals to RT equals to R. So if I replace all the resistors with the value of R, so this is the next expression we will got, and then we can get VAB equals to R into VDC divided by 2R plus change in R into 2R in bracket this value. Okay. If we simplify this, we will get these values properly. So then VAB in final expression we can write here change in R into VDC, so divided by 2 into bracket of 2R plus change in R, if I simplify this. Okay, so this is very simple simplification, you can do this. Okay, so after this we'll go for the total output voltage which we are going to measure here. So here the total output voltage at this meter output stage, if I consider it has a inverting operational amplifier, then the gain of this is V0 is nothing but minus RF by R1. This is RF, this is R1. So minus RF by R1, okay, into AV, that is the gain here, that is AV. So that can be written here in the simple fashion. So that is here V0 is nothing but now VAB acts as the input, V0 is the output. V0 by VAB is nothing but gain here, that is nothing but minus RF by R1. So here RF by R1 will take one side and VAB is at the another value. Okay, here we got VAB as a negative, okay, because we have taken here VAB equals to here we have taken here we have taken here VAB equals to VA minus VB, right? So that can be changed of VB minus VA, then minus sign can be removed here. The same thing has been done here. So that's why V0 equals to VAB. So minus of RF by R1 becomes positive, okay, because minus into minus get plus here. So that's why the last expression can be written in positive RF by R1 and substitute the value of VAB here. Okay, so this is about the instrumentation amplifier. Okay, a simple explanation using the internal circuit diagram of op-amp with bridge rectifier, with the Wheatstone bridge and output stage meter. Okay, so if you have any doubts, you can text me a message. Thank you.